Lesson 11, Example 3. In this video, we are going to graph f of x is equal to the absolute value of x if x is less than 3, and negative x plus 4 is if x is greater than or equal to 3. So I'm going to set up two tables of values. The first one is for the function the absolute value of x, and the second one will be for the second function negative x plus 4. Remember that the if statements up here, which I guess there should be the word if, are the rules for what you can plug into the table. So for this table, x has got to be less than 3, and for this table, x would be greater than or equal to 3. The one exception for the table on the left is that since 3 is a boundary number, it has to go in the table. That's just where we'll graph the open circle. Now, I've said in class I would like at least two other values. Those two other values have to be less than 3. So I'm going to pick a negative number and 0. So if I plug in 3, the absolute value of 3 is 3. The absolute value of negative 1 is 1. And the absolute value of 0 is 0. So now to graph this piece of the function, I'm going to have the point 3, 3, but there I'll have an open circle. I'll have the point 0, 0, and I'll have the point negative 1, 1. And if you remember, the graph of an absolute value function is V-shaped, so it's going to look like that. Looking at the second function, in this function, we're going to graph f of x is equal to negative x plus 4. I have to put 3 in my table of values because that's a boundary number. But in this case, since there is an equals to, I'll put a closed dot. The other two numbers that I'll pick have to be greater than 3. So I'm going to pick 4 and 5. So plugging these into the second function, negative 3 plus 4 would give me 1. Negative 4 plus 4 would give me 0. And negative 5 plus 4 would give me negative 1. So now if I graph those, I have 3, 1, 4, 0, and 5, negative 1. So that is in the form y equals mx plus b. So this will just be a line. Forgive me for my squigglies. That looks like that. All right, so that is the graph of this function. So now to determine the domain and the range and the intercepts, well, this function is going to go forever from left to right. So the domain of this function is negative infinity to infinity. The range of this function, if I squeeze that into the y-axis, the whole y-axis would be covered. So the range of this function is also all real numbers, or negative infinity to infinity. And I have two x-intercepts, one at 0, 0, and one at 4, 0. The y-intercept is at 0, 0, which I already have listed. So those are the only two intercepts of this function. It is important to note that a function can have more than one x-intercept, but it can only have one y-intercept. Otherwise, it would fail the vertical line test.